Okay, so today we're graphing rational functions. Well, sort of. They're already graphed. We just need to figure out which graph is correct. And the way we do that, instead of having to type the whole thing into a calculator, making a table and filling in values, is we can look at our key features that we looked at the last 2 days. So we look for our point discontinuity, our holes. We look at our vertical, horizontal asymptotes. Okay, so I should start with the second example because it's a little bit easier to work with. And I notice my difference here is one has a vertical asymptote at -4, the other one has one at +1. I don't see any holes anywhere. So we're going to, and every time, we're just going to factor out whatever we can. So x squared minus 16, that's a difference of 2 squares. It's going to be x plus 4, x minus 4. Okay. On the bottom, we have, factor out a -4 here. So -4, that's going to leave x, and then remember to flip the sign here, right? 4 divided by -4 is -1. So we can see there's nothing to cancel out here. So there's no point discontinuity. We are going to have a vertical asymptote. Remember, that's just what value will make your denominator equal 0 once everything has been factored. So if we have x minus 1, then we know we're going to have a vertical asymptote at the opposite of -1. Asymptote, if I can remember how to spell. So that's going to be at x equals +1, right? Because if x equals 1, 1 minus 1 is 0. 0 times -4 is 0. You cannot divide by 0. So this function cannot exist where x equals +1. So that becomes our answer. Okay? So we're doing the same thing we did the last 2 days. Factor out best we can. Simplify to find our point discontinuity. Look at what's left over to determine which points don't exist. That's our asymptotes. Okay? So let's try this slightly more difficult one to the left. And we're going to factor best we can. So I see x to the third, x squared, and x on top. So I know I can factor out 1x. It's going to be x squared plus 6x plus 8. On the bottom, I see -3x squared. So I want to get rid of that one. So if I factor out the -3, that's going to leave me x squared. -21 divided by -3 is +7x. -36 divided by -3 is +12. Okay. So now I have a couple of factorable quadratics here. So on top, I'm going to have x times, let's see, x squared, 6x, and 8. So that's going to be x plus 4, x plus 2, right? 4 times 2 is 8, 4 plus 2 is 6, that works. On the bottom, it's going to be -3, let's see, 7 and 12. So that's going to be x plus 4, x plus 3. Okay, let's see, 4 times 3 is 12, 4 plus 3 is 7, that works. Okay, once everything is factored, we look to see, do we have something in common? We say, yes, we do. This x plus 4, right? So our point discontinuity, will abbreviate, is going to be the opposite of that value. So if it's x plus 4, then our hole is going to be at x equals -4. And if we look at our 2 answer choices, one of them has a hole, one of them does not, which means our best answer is going to be A, right? We do have this vertical asymptote, but both of them are listed as x equals -3. And that checks out, right? Because once we cross out the x plus 4, we still have this, oh my goodness, change colors. We still have this x plus 3. So we said after we've simplified as much as we can, any x's left over in the denominator, we set those equal to 0, and those will be our vertical asymptotes. So that is going to be vertical at x equals -3. Okay, which doesn't help us for this question, but you will need to be able to determine that. So every time, factor as best you can, simplify if possible. That'll tell you if there's a hole in your graph or not. I believe on all of these, you'll have some sort of vertical asymptote. So whatever x values are left behind in your denominator, you solve for what will make that equal 0. At least one of these, you need to remember your rules for horizontal asymptotes. So remember, if the higher degree is in the numerator, then there is none, right? We don't see any horizontal asymptotes here. If the higher degree was on the bottom, right? So if this was 4x to the third, then your whole graph would look different, but you would have your horizontal asymptote at y equals 0. And if they are the same degree, so if these were both x squared, remember you look at the leading coefficient for both, and so we would say this would have a horizontal asymptote at -1/4, which would be a little bit under the line. Okay, so that's how that works. Remember, horizontal, you just look at the degrees, and then you remember those 3 rules from Monday, or you rewind back like 1 minute to when I just explained all 3 of them. So try them out. Make sure to show your work, because that's half of your grades today. All right, good luck. Bye.